we will be exploring the world of complex numbers. Just when you think there were no more numbers to learn, now we've got more. How did these numbers come about? Well, we want to solve equations like this. X squared equals to negative 4. Up until now, you've been taught anything you square becomes positive, so that's not possible. Well, now we're going to make it possible. In order to solve this equation, we're going to introduce the square root of negative 1 and the set of what's called imaginary numbers. For convenience sake, instead of just writing the square root of negative 1, the math world has decided to represent that square root of negative 1 with the letter I. I think the word imaginary is very misleading. These are not make-believe numbers, they are just called imaginary. I wish they would have called them something else. But this is what we're stuck with. So we're going to represent the square root of negative 1 with I. Now let's back up. Do you remember what happens when you square the square root? Remember that square root goes away. So that leads me to the next line of analysis. If we square the square root of negative 1, and the square root of negative 1 is I, so we could write that as I squared. We also know when we square root and we square, they cancel each other out, so I would just get negative 1, which means negative 1 equals to I squared. Now let's just say that again. Right? So if the square root of negative 1 is I, and I square both sides, that's really what's happening. When you square a square root, that goes away, and that's just I squared. That little fact right there is going to become very important in this lesson. But let's just take it one step at a time. Let's just learn how we can write things with I. The square root of negative 2 can be written with I times the square root of 2. Now most books write it as the square root of 2 times I. However, you don't want to put that I underneath the square root sign like that. That's wrong. And so I just prevent that by putting the I on the outside. But either way is correct. Now, what's the square root of positive 9? It's 3, but because of that negative, we put I. Same thing here. The square root of positive 4 is 2, but because of that negative, we put I. You might say, why? Well, because the square root of negative 4 is now defined to be the square root of negative 1 times the square root of 4. That part is the I, and that is the 2. So that's how I'm getting 2I. So 12, remember we can break that apart. So we can take out a 2 and leave a 3, but because of that negative, that's that square root of negative 1, we're going to rewrite that in terms of I. So what we're going to do today is we're going to learn how to add, subtract, multiply, and divide what's called complex numbers. And a complex number has a real part, which are all the numbers you learned up until today, and then what's called the imaginary part. It's called A plus BI. A is the real part, and that BI is the imaginary part. The good news is to add, subtract is very easy, because really all you want to do is collect like terms. So first of all, notice that there's a plus sign between here. So this is just negative 4 plus 7I plus 3 plus 2I. At this point, you can treat I just like you would X. Just collect like terms. So I'm going to put the real parts together, then put the imaginary parts together. That's it. Really, that's it. What makes this difficult is a lot of students just don't see that minus sign, so we want to distribute that. And then again, we're going to collect like terms. So here's the real part, here's the imaginary part. And you're done. Now look at this third example. What's between those parentheses? Nothing. So this means to multiply. But here, that means to add, and here, this means to subtract. So on the next test that you take with complex numbers, don't be so quick Look and see what's between those parentheses. Are you adding? Are you subtracting? Are you multiplying? So now let's go to that multiplying. You would just FOIL it just like you learned a long time ago. So first, out, enter, last. Right? And I times I is I squared. Now, the only new part is we're going to replace I squared with -1, and we are also going to collect like terms. So we're going to have 8, those are alike, plus 22i. I'm going to replace I squared with -1. So what happens when I multiply a -1 times a positive 15? I get a -15. Not done, because now those are real numbers. I can add those together and I get a -7 and then plus 22i. So you're going to FOIL it, and then you're going to replace any I squares with -1. Okay, what happens when you see something like that? It means to write it out twice, or do that in your head, either way, and we're still going to FOIL it. Okay, so 4 times 4 is 16. We have -4i, -4i, plus I squared. Now hopefully you might even be able to just write down 16 minus 8i plus I squared, and that would be great. All right, so we're going to collect like terms, those together. That's how I got the -8i, and then I'm going to replace I squared with -1. So now I have just -1. Collect like terms, and you're done. So adding, subtracting, and multiplying, very easy. Multiplying, you got to replace any I squares with -1. Now we're going to look at the little trickier part, how to rationalize denominators. Well, remember, rationalizing is to get rid of the square root. So this is a review, something we've done previously. We have the square root of 2, so that's what I would multiply by to rationalize the denominator. And then we would have 5, which is there. The square root of 2 times the square root of 2 is 2. And I have rationalized that denominator. So we're going to do that same thing on example number 5. And you're going, but there are no square roots. But yes, because I is the square root of -1. So you want to get rid of any i's in the denominator. So just like this one, I only multiplied by the square root of 2 because that 5 was still okay. I'm only going to multiply by I because that's that square root of -1. Let's multiply that. You're going to have 2, and then I times I is I squared. On top, we're going to distribute. So I have 3i minus 5i squared. Now what did we do when we did that multiplication before? We replaced all the I squares with -1. All the I squares with -1. So we have 3i, then -1 times -5 is +5, and now we have over -2. You can write your answer like that, or let's try something different. What if I broke that apart and had 3i over -2 plus 5 over -2? Or I can put the real part first and the imaginary part second. And remember, those negatives can go anywhere, top, bottom, or out in front. So this is okay, this is okay, this is okay, just to let you see how different books might express their answers. So before we leave this example, remember when you had a monomial, you just multiplied by the square root to get rid of that. Now what happens when you have a binomial in the denominator? Well, we just saw that on the last video. Something like this. We multiplied by the conjugate, which was the same binomial except the middle term. And why did that work? because when you FOIL this out, the middle terms cancel, and you just squared the first term, squared the last term, and subtracted, and you didn't get any radicals left in the denominator. And then, of course, we distributed that. Well, we have what's called the complex conjugate. It's the same thing. You change the middle sign. So let's see what happens when we multiply complex conjugates. We would FOIL, and of course the middle terms canceled out just like before, but now we have that I squared that we replace with -1, and so we have 9 not minus 25 but plus 25. So when we multiply conjugates, we're going to square the first term, square the last term, but you're going to end up adding. So let's look at problem 6. Okay, we have a binomial with an I, which is a radical, so we want to multiply by what's called that complex conjugate. So we're going to change just the middle sign. On the bottom, we multiply, we get 9. We multiply, we're going to get 25, but it's going to become plus because of that negative and the I squared, which of course is what we just did here. Then I'm going to distribute, so I have 6I plus 10I squared. And now you should be saying, oh, I don't need to write that I squared, I just need to know it's going to change the sign because we're multiplying by -1. So I have 6I minus 10 over 34. Well, that's great, but we're not done. Let's circle all of our numbers that are not inside radicals. Can we reduce 6, 10, and 34? Yes, they're all even, so I can divide by 2. So that would be 3I minus 5, and 2 goes into 34 17 times. A lot to remember. Complex conjugates, multiplying, changing I squares to -1, and then reducing. Let's look at one last example, a little more complicated. All right, so we have that binomial in the bottom. We keep the -5. Remember that complex conjugate is you just change only the middle sign. Only the middle sign. Okay, let's do the bottom. -5 times -5 is still positive 25. Now 4 times 4 is 16, and because of we're going to have the I squared, which makes -1, and that's negative, we're going to add the product of complex conjugates, square the first term, square the last term, add. On top, we're going to have to FOIL. So we're going to have -15, -12I, -10I, -8I squared. And again, hopefully you're thinking, I need to change that to a -1. So we're going to have -15 minus 22I plus 8 over, it looks like, what is that, 41? Still not done because I can still collect like terms. So that's -7 minus 22I over 41. To add, subtract, and multiply is very easy because you just do what you've done before. Just make sure you look for the plus, the minus, or you know it's multiplying. You're going to replace I squared with -1. If you're dividing, which means you're rationalizing denominators, and you have a monomial, you're just going to multiply by what's in the square root, which is usually just the I. But if you have a binomial, you're going to multiply by what's called that complex conjugate, and you're going to end up adding those because, again, of that I squared.